conclude with a super quick demo that connects the activity where you built a peanut butter and jelly sandwich by talking your TA through it. At first glance, something like this doesn't seem to have any relation to computer science, right? However, as we've discussed, CS is all about breaking down problems, and the problem you were faced with here was one that computer scientists struggle with all the time. How do you give the perfect instructions to something that will follow those instructions no matter how dumb or incorrect they seem? As I'm sure you discovered, using English to get a computer to do what you need it to do is frustrating, to say the least. And so the way computer scientists have traditionally dealt with this problem is by developing programming languages. Now, there are all sorts of programming languages, from the drag and drop kind that beginners can use to master concepts, to more industry standard languages like Java or Python. Unfortunately for us, even using programming languages isn't foolproof, and computers can still find a way to be cheeky and avoid doing what we want them to do. As computer scientists, we like to call these mistakes bugs in our program, and even experienced programmers like me still run into buggy programs every now and then. So I just wanted to show you an example of a bug that was a result of me not being specific enough with my computer and telling my computer what I wanted, but not well enough. In this demo, we'll examine a problem I had to solve for my artificial intelligence class, and it looks a little something like this. So don't worry about the massive wall of text, just focus on whatever's in the blue rectangle and whatever's underlined. So in corner mazes, there are 4 dots, 1 in each corner. Our new search problem is to find the shortest path through the maze that touches all 4 corners. Okay, let's put that in a little easier terms. So essentially, we have a maze, and that maze has 4 corners, and we have control of PacMan. Our goal is to touch all 4 corners with PacMan. Again, don't worry about the specifics. This is stuff you see and work with after years of experience, so it's completely fine to not understand what's going on in the code. Just follow along. So to make this a little more concrete, let's just watch what that actually looks like. What are 4 corners in a corner maze in PacMan? What is that? So here's the first example, and this is a tiny maze. PacMan's going around, eating all the corners. Let's see this with a slightly bigger maze. Alright, so there's PacMan. He's getting each of the dots in each of the corners, and when he's done, the game will be over. 3 out of 4, and 4 out of 4. Great. So what we just got to see is an example of the problem that we were given being solved correctly. Now let's take a look at my first attempt to solve the problem and see why that went wrong. Okay, so same maze, different results. Why? There's PacMan, he's going. Whoa, what was that? What went wrong here? So let's watch that again, and let's think about what possibly went wrong here, okay? There he goes, and he's getting stuck. So it looks like PacMan is getting confused. He visits the nearest corner and then just keeps visiting it a couple times before randomly stopping. A bug, because that's not what we want him to do. Like we said before, we need him to visit every corner, and he's only visiting 1. So eventually I figured out the bug, and it was in how I thought about the problem and how I told the computer to solve the problem. Essentially, I'm going to change 1 number in the actual code. Okay? So, and that's number of corners. Okay? I'm going to change the number of corners from 4 to 20. And do the same up here. Okay. 20. Alright. And let's just see. We're going to see something a little bit different. And I want us to think about what's going on. Okay, there goes PacMan. Whoa. He gets stuck at the same corner for longer this time. I changed the number of corners to be 20 instead of 4. So if you were really paying attention and counting, it turns out that PacMan visited that same corner a bunch of times, 20 to be exact. Back when that number was 4, he visited the same corner 4 times, and by changing that to 20, he visited it 20 times. So the logical flaw here is that I need him to visit all 4 corners, okay? So if I let him go, I don't want him to visit just 1 corner. I want him to visit all 4 corners, not just the same corner. And so the fix would then be to code it up so that he visits all 4 corners, just not the same corner over and over again. So it should look something a little bit like this. Let's get rid of that. Let's see the medium corners again. So we want him to visit all 4 corners, not just one corner 4 times. And that was something that it took a little time to get my mind wrapped around. It's not something I initially thought of, and once I did think of that, I was like, wow, these computers, they're tricky, man. They're tricky. So what I hope this demo has shown is that everyone can make mistakes, big or small, and that with computer science especially, it pays to be really, really explicit with the instructions you give your computer. Otherwise, PacMan will try to be lazy and not visit each corner of the board. He'll just try sticking to one corner, and that's not what we want. We want our computers to be able to solve our problems, not do whatever that they want to do. So with that, I wish you good luck, and I think this was a really great demo to kind of illustrate the pitfalls in computer science. Everybody makes mistakes, and programming languages are a really great way to make less mistakes, but there are always going to be bugs in programs, and it's our job as computer scientists to come together and fix that.